Hey everybody, welcome back. I'm going over Chapter 12, Section 5, volumes of pyramids and cones in this video. To start off, let's talk about the volume of a pyramid formula. It's 1/3 times the area of the base times the area of a height. Now, if you'll recall from the previous section, the volume of a prism was area of the base times the height of the prism. So the reason why it's 1/3 for a pyramid is that you can chop up a prism into 3 congruent pyramids. And so if you piece together those 3 pyramids, it would look like that prism. So because of that, then you can say the volume of it is 1/3 of the area of the base times the height. So here are the first 2 examples. They're really straightforward. This is a rectangular base, so area of the base is 9.5 times 8, and the height of the pyramid is 9, so I did 1/3 times 9.5 times 8 times 9. I get 228 cubic centimeters. The next one, this is a 1, 2, 3, 4, 5, 6-sided base, and so what's that, a hexagon? So this is a hexagonal base, but you don't have to figure out the area of that. I say capital B is 22, so I just plug in 22 times 5 times 1/3, and that's it. Now on the next 2, I'm working backwards. So the volume was 64 cubic inches, so I set it equal to the formula. 64 equals 1/3 big B little h. So big B is 8 times 4. I know that. That's the area of the base. I don't know the height of the pyramid. So what I did was 8 times 4 is 32, and 32 times 1/3 is 32 over 3. It makes a number with a decimal, but that decimal goes on forever. So it's a better idea to keep it as a fraction. So there's 2 ways you can get rid of fractions. Flip it and multiply it to the other side, or just divide it, but make sure you use parentheses. So that's a key thing there, is to use parentheses. So I did 64 divided by 32 over 3 in parentheses, and I got 6. All right? Now, this one is a little bit different. So to start off, we have a triangular base. Okay? And so if it's 1/3 times the area of the base, well, the area of the base is the triangle, so that's going to be 1/2 base times height. So I'm looking at the base of the triangle, which is 6, and I'm looking at the height of the triangle, which is unknown. But I do know that 10 is the hypotenuse of that triangle, because you can see that it's across from the right angle right there. So I just did the Pythagorean theorem going backwards. I did 10 squared minus 6 squared, took the square root of that, and that got me 8. 8's the height of the triangle. So for the area of the base, I just did 1/2 times 6 times 8. And then I plug in the rest. I times that by 1/3. I don't know the height of the pyramid, so I can simplify all this though. 1/3 times 1/2 times 6 times 8 just makes 8. So that's why it says 8x equals 56. So divide 8 to both sides, and I get 7 meters for my final answer. All right? So let's go on to the next page. So the volume of a cone, it's the same formula, 1/3 big B little h. And it's the same principle. If you were to drop a cone inside a cylinder, well, you'd have these 2 like oblong looking cones. You'd have room for two cones to fit inside this cylinder. So therefore, 1 cone takes up 1/3 of the volume of a cylinder. So if you don't remember the area of the base is always going to be a circle for a cone, so that's pi r squared. So there's your formula. So this first one, 1/3 times pi times 3.2 squared times 5.8. And pi r squared was pi 3.2 squared. That's the area of the base. This next one, a little bit different. If I'm doing 1/3 pi r squared, well, I got 1/3 pi times 10 squared. I can do that right up top. The only thing is I can't multiply it times the height of the cone yet, because I need to figure that out. So what we have here is a special right triangle. I have a 45-degree angle right there. So if I have a 45-degree angle right here, I just drew the triangle. So I got 45 there. That means I got 45 here as well. So you got to remember what to do for 45, 45, 90 triangles. So I put a picture of it over here on the side. And you see that your two shorter legs are just x, and your longest leg is x square root 2. And so if you'll recall, if you have a whole number for that x square root 2 side, then the pattern is cut that number in half and throw a square root 2 next to it for the two shorter sides. So I have h, and I wrote h equals x, and I put x on the bottom as well because that's how it was in the formula. Both of those, the bottom and the side, are 9 square root 2. That's half of 18 with the square root 2 next to it. Okay, so that's the height of the cone. So now I just plug that in, and I got my final answer of 1,332.86 cubic yards. Okay? Now this last one was find the missing measure given the volume of the cone. So the volume of this cone was 147 pi cubic centimeters. And I give you the height of the cone, but not the radius of the cone. So let's see what I did. Okay, it's 1/3 area of the base, pi r squared, pi x squared, times 9, 9's the height of the cone, equals 147 pi. So what I did first is I did 1/3 times 9, and that makes 3. And so I just realized it says 3 pi x squared. I can divide out 3 pi now. 147 divided by 3 pi actually makes 49, but I kept it as a fraction just so you wouldn't get lost as to where the 49 came from. But yeah, so you don't have to leave it as a fraction, but it doesn't matter. If you type in the square root of the fraction of 147 over 3, you're going to get 7. But yeah, the important thing to notice, at the very least, is your pi's would cancel out. And that's always nice, because then you don't have these long decimal answers. Or you might not. But that's it for the notes. Stay tuned for the next video. We're almost done for the year. So, yeah, I'm getting teary-eyed just thinking about it. Nah, I'm not really getting teary-eyed. But, hey, if you're still listening at this point, you should ask me, hey, sir, did you get teary-eyed? And the answer is no. No, I did not. All right, goodbye.